We'll be moving to our next speaker now, who I'm personally a huge fan of. Up next, we have Liz, who's head of developer relations at NodeSource, who will be giving us a talk on examining observability in Node.js using Strapi. So, round of applause for Liz. Questions in the Discord.
Hello all, I am Liz Parody, Head of Developers Relations at NodeSource, and today I will be talking about examining observability in Node.js using Strapi. This is the agenda for today. First, we're going to talk about what is observability, then why is observability important, external tools for observability, benchmark. Finally, we will do a little demo for observing a Strapi app and conclusions at the end. Let's begin by understanding what is observability. Observability is a term from control theory. A simple definition could be is a measure of how well internal states of a system can be inferred by the knowledge of its external outputs. In other words, we see the results or the output and we can know what's happening inside. Let's take, for example, bananas and avocados. In Colombia, we have a lot of bananas and avocados, and just by looking at the outside, we can know what is on the inside, in the ripped or if they're not ready for consumption yet. In software products and services, observability means you can answer any questions about what's happening on the inside of a system by observing or asking questions from the outside of a system. We don't need it to ship new code to answer questions, and that's very important. We shouldn't need to write new code to observe what's happening inside of our system or our code. Because system complexity is outpassing our ability to predict what's going to break, there are super useful tools that come to the rescue. Now that you know what observability is, you will be wondering why it is important and why you should care. With environments as complex as we see today in modern applications, simply monitoring for problems is not enough to recognize, find, and fix a number of issues that arise. Sometimes the new issues are unknown unknowns, which are problems you don't know, and even worse, problems you don't know how to find. So without tools to observe the environment, it's almost impossible to solve these issues. This is why observability is important. It gives you the instrumentation you need to understand what's happening in your software and fix it. A good observability tool helps you find what and where the problem is. It doesn't add overhead to your app. We don't want our app to slow down. Quite the opposite. It has enhanced security. We don't want any data breach, has flexible integration, and doesn't need to modify your code. It's important to differentiate between observability and monitoring. Observing is exposing the internal state to be viewed externally, and monitoring is collecting and displaying the information that has been exposed, and usually involves writing automation tools around that. If you want to solve the most complex Node.js problems such as memory leaks or performance issues, or just follow the best practice to keep your code healthy, it's necessary to have an observability tool. The next step will be choosing an observability tool that adapts the best for our needs. The ability to correctly monitor the process is limited by how much data is exposed. How that data is exposed are the observability tools that we're going to see next. External tools for observability. First, we're going to see New Relic. New Relic is an observability platform built to help engineers create better software. From monoliths to serverless, it helps you to instrument everything, then analyze, troubleshoot, and optimize your entire software stack, all from one place. It also provides different solutions from cloud adoption to digital customer experience, and this is how New Relic insights appear. You can see web transformations time, the application activity, error rate, host, and others. The next one is Datadog. Datadog is a monitoring service for cloud-scale applications, providing monitoring of servers, database, tools, and services through a SaaS-based data analytics platform. With Datadog, you can check requests, latency distributions, error, percentage of time spent, and other metrics of your Node.js applications, as you can see here. The next one is Instana. Instana is an application performance monitor, APM, for microservices. It lets you manage the performance of your applications in real time and see every detail about the inner workings and inner dependencies of your application services. We can see some metrics like calls, error rates, mean latency, top services, processing times, and others. The next one is Dynatrace. Dynatrace produces a software intelligence platform based on artificial intelligence to monitor and optimize applications performance and development, IT infrastructure, and user experience. For Node.js observability, it can tell you the number of processes, CPU and memory usage, the percentage of connectivity and availability, traffic, the most time-consuming requests, and other Node.js metrics. But there is a problem with all of these solutions. The way APM works is they become agents which are intermediaries between your application and the Node.js runtime. The APM is injected into your code and it encapsulates your application so they can extract the information, and that has a significant cost, also known as an overhead. Another problem is that sometimes you have to modify your own code in order to implement the APM. Code instrumentation, which create extra work and a layer of difficulty that we don't want to deal with. Also, accuracy is questionable, but they can be very useful tools that provide you with additional insights and extensive data. Now let's see one tool that doesn't have this problem because it's not an APM. It's an enterprise runtime for Node.js and it adds minimum overhead. I don't have to modify your code at all. NSolid. NSolid is a drop-in alternative for the Node.js runtime, enhanced to deliver low-impact performance insights and a great security for mission-critical Node.js applications. It has faster time resolution and zero code instrumentation. That means you don't have to change your code in order to implement it. This is important because traditional APM tools sit on top of Node.js runtime layer. Performance overhead might vary from one application to the next depending on the architecture and stack used. Other tools are not built specifically with Node.js in mind. NSolid was built specifically for Node.js. It's a Node.js runtime itself, not an agent. Here we can see how some of the metrics are displayed, like the dashboard where you can see each process, heap use, CPU percentage, and others. It is important to clarify that the previous tool I showed, they all contain libraries that help you expose data, but the main function is as a monitor. For example, I cannot expose data using the New Relic API and consume it via AWS. This is where NSolid has an advantage. The additional metrics NSolid provides can be consumed by any monitoring solutions and without any additional overhead. The best of both worlds. Finally, and now that we have seen some tools for observability, let's see some benchmarkings that compare the most important features for an observability tool. If we're going to check load times, which is the time it takes for a Node.js process to be available to receive and process requests, we can see vanilla Node.js is the fastest with 30 milliseconds, followed by NSolid with 40 milliseconds. Then we can see Instana with 210 milliseconds, which is an increase of 600%. New Relic, Datadog, and finally, AppDynamics, which is an increase of 3,600%. Startup times, we can see that Node.js takes 30 milliseconds in the startup time, followed by NSolid with 35 milliseconds, then 150 and 250 milliseconds by AppDynamics and Datadog, which is an increase of 600%. Adding baggage or memory overhead, NSolid only adds 2 megabytes of memory, while New Relic and Datadog adds 15 and 57 respectively. Finally, measuring speed, NSolid is the fastest one with almost 10,000 requests per second, then AppDynamics with 2,000 RPS and Datadog with 1,500 RPS. Now, let's do a little demo to observe what's happening inside a Strapi app. First, let's just use a Strapi template. I'm going to use the e-commerce one. So I just create the template using the command yarn create Strapi app, folder name, dash template, and the repo URL. I choose the quick start option. Then we wait for a few moments while it installs everything. Then it goes to localhost 1337 and it displays the registration page. I fill all the fields required and I press the Let's Start button. And voila! It shows me the amazing Strapi landing page where we can see a tutorial, blogs, documentations, examples, and of course the Strapi community. Because we use the e-commerce template, if we go to categories, we can see the ID, name, slug, products, and on the right, we can duplicate, edit, and delete categories. If we go to products, we can see all the products with its ID, title, description, price. We can add products and filter them. An amazing user experience, a great CMS. Very easy to customize and create performant content APIs. Then we have content types builder, media library, marketplace, plugins, and others. If we want to observe what's happening in this simple e-commerce API, first we go to the working directory and we connect the process with NSolid using the command export NSolid command localhost 9001. Then we just type NSolid console and go to localhost 6753. We can select the project. We select the process and we will be able to see the important metrics such as CPU use, memory, host load, async data, event loop, and others. And if we want to see other metrics, we just select them. We can take heap snapshots and CPU profiles over here to get greater insights of your Strapi applications. In general, if we take a quick look, we can see that all the metrics are looking good, which means that the Strapi app is highly performant, secure, and reliable. And by far, the easiest and possible the best solution for jumping into the headless CMS world, and even better as an API framework to power whatever your needs are: web, mobile, desktop, IoT, and others. As a conclusion, observability in Node.js is very important for security and performance. It allows you to fix errors faster, and if you're focusing on Node.js specifically, NSolid is the best observability tool out there. The other tools are great, but they come at a cost because they are noticeable overhead from wrapping the user's code in their own libraries. NSolid avoids this penalty by observing the application at a lower level, allowing NSolid to make observations without directly affecting how the program runs. For other types of applications, and depending on your needs, there are other great observability tools that adds a lot of value. Thank you. Bye.
Really great talk, Liz. Hands up in the chat if you just found out about the concept of observability. It's such a cool concept. And thanks, Liz. Thanks so much for your talk. We've come a long way on the Strapikoff journey, and I just wanted to say how much I really appreciate all of you for joining us. As has already been stated multiple times during the conference already, we could not have done this without you.